Hello again, Mrs. Hoekstra here. We are on Module 2, Lesson 8. I'm on page 53 of our book, Applying the Properties of Operations to Add and Subtract Rational Numbers. All right, the essential question today: how do properties of operations help to find the sums and differences of rational numbers? How do properties of operations help to find the sums and differences of rational numbers? Sums, right? Answer to an addition problem, right? Differences, it's the answer to subtraction problems, right? Rational numbers, those are just the numbers that we're used to working with. Fractions, decimals, whole numbers, any of those types of things. All right, so example 1. The opposite of a sum is the sum of the opposites. That's kind of the big idea that we've got going on right now. Okay, so what I want to do is kind of just like randomly pick some numbers. Okay, I'm just going to randomly pick so that you kind of go, where in the world did you get them? I'm just going to pick 7 and I'm going to pick -2. Okay, you could pick any two numbers you want, but I'm going to pick 7 and -2. All right, so my first rational number I said was 7, and my second rational number was -2. All right, and then in this box here, in this table, I'm just going to take their sum. Now remember, when I add with different signs, I actually subtract and use the sign of the bigger number, right? 7 is my bigger number, and so my answer ends up being 5. All right, well, read the next column over. It says the opposite of the sum. Well, what's the opposite of 5? The opposite of 5 is -5, right? You could literally say that as the opposite of 5. The opposite, instead of saying negative, you could say, call it and literally read it as opposite of 5. Instead of saying -5, just say the opposite of 5. Well, according to this, explain the meaning of, right? It says the opposite of a sum, which we know is now -5, is the sum of the opposites. Okay, it's the sum of the opposites. Well, what's the opposite of my 7? -7. And what's the opposite of my -2? It's +2. Again, go back to which is bigger, 7 or 2? Well, 7's bigger, right? So I know I'm going to have a negative answer, and I subtract them, and I get 5. What do you notice about the two answers? Okay, they're the same, exactly, they're the same. So you should catch that. So the opposite of the sum is the sum of the opposites. I can say them either way, and I should get the exact same answer. The opposite of a sum is the sum of the opposites. All right, let's go on to page 54. Exercise 1, it says represent the following expressions with a single rational number. And if you notice, oh, there's my favorite, there's fractions. Oh, this is awesome. Not only that, we do have one issue though, because I have -2/5. I have a +3 1/4 minus a 3/5. And you'll notice that there's that 1/4 there. Let's not worry about it right now, okay? What I want to do is just kind of rearrange these numbers around, okay? I just feel like rearranging these numbers. So in fact, what I'm going to do is start off by rewriting this as -2 2/5 plus 3 1/4 plus -3/5, right? I want to change that, write it up that way so that I have only addition, because let's just pretend you can't subtract, okay? And then what I want to do is rewrite it one more time. -2 2/5, nothing's changed. And then I want to write plus -3/5, right? And then plus the 3 1/4. If I set it up like that, I now have fractions with the common denominator next to each other, right? I've got these two here, right? They both have that common denominator, so I should be able to add those pretty easily. Well, the other thing I want to do is use this idea of being able to break these numbers apart, okay? So what I want to do is I want to break -2 2/5 into -2 plus -2/5, because that whole entire thing is negative. I'm just going to break it into those two negative parts, and then plus -3/5. Okay, nothing's changed there. And then that 3 1/4 is still out there. Okay, I'm just going to deal with these numbers that I put in parentheses. You didn't have to put them in parentheses, but I just want you to understand that that's where I'm working right now. Okay, I actually think I want to work with those fractions first, right? -2/5 plus -3/5. Well, the signs are the same, right? Those signs are the same. So that means I can actually just physically add them. -2 plus -3 is -5. So I'll have my -2. That stays there. This becomes -5 over +5. Okay, and then my 3 1/4 is still out there. No big deal. Well, what's -5 divided by -5? Now I've run out of room, so I think I'm just going to come up over here and start working over here. So I really have -2. I'm just going to rewrite it as -5 over 5, and then plus 3 1/4. Okay, I'm just going to rewrite it so we don't get lost. And what do I have? This right here is actually just -1. -2 plus -1, and then plus 3 1/4. Notice I got rid of my fractions. They're gone. Okay, well, what is -2 plus -1 going to give me? All right, now I'm going to have to go off to the side. So I actually have -3 plus 3 1/4. Well, what's bigger, 3 or 3 1/4? Exactly, 3 1/4 is bigger. Not a lot, but it is bigger. Okay, so I know my answer is going to be positive, and then I'm actually going to just subtract. What's -3 plus 3, and then I'm going to break that into plus 1/4. If I break it up that way, right, break this up into 3 1/4, and they're both positive. Now I've got -3 plus -3. Oof, what a grand mess here, Mrs. Hoekstra. That is equal to 0 plus my 1/4. Oh man, how are you guys going to find this answer? My answer is 1/4. Wow, I apologize for that big old mess. It's all over the place. Well, let's try it again on example 2. Maybe it'll be a little neater on this one. Okay, use the number line model shown below to explain and write the opposite of 2 2/5 as the sum of two rational numbers. Okay, so basically what I want to know is, how do I write 2 2/5? Right? 2 2/5 is the same as 2 plus 2/5. Right? I can just rewrite it into two separate parts. Or I could say the same thing with -2 2/5. That's the same as -2 plus -2/5. Okay, I can rewrite those and get those same numbers. Okay, I can split them up, and by splitting them up, it makes it a lot easier for me. Okay, so the opposite of a sum, the top single arrow pointing left, and the sum of the opposites correspond to the same point on the number line. Okay, the opposite of the sum is the sum of its opposites. I want to kind of make sure we get that. The opposite of a sum is the sum of its opposites. That's not an apostrophe. Okay. The opposite of a sum is the sum of the opposites. So for example, right, if I gave you 7 plus 2, the opposite of that sum, well, what is 7 plus 2? It's 5, right? The opposite of that sum, I'm just going to have the opposite out front, is the sum of the opposites, -7 plus -2. And sure enough, that is equal to, what in the world? Mrs. Hoekstra can't add. What's 2 plus 7? Why did I say 5? I was subtracting. That's 9. And then this would be -9. Man, I think it's time for me to go take a nap or go to sleep. All right, there we go. Let's go to page 55. All right, exercise 2. Rewrite each mixed number as the sum of two signed numbers, just like I did on page 54, right? The middle of page 54, example 2. I want you guys to do that. I want you guys to do exercise 2 And exercise 3 on pause. I'm going to pause here a minute. Do those on your own, and then turn it back on when you're ready to hit and go on to exercise 4. All right, so go ahead, hit pause. All right, so did you get for the first one, -9 plus -5/8? And then part B, -2 plus -1/2. And then C should be 8 plus 11/12. Just split them all up, right? Split them up into their parts. And if the beginning tells you it's negative, the whole thing is negative. All right, and then example 3, go the opposite direction, right? I'm going to take these two and put them together. So I should have -1 and 5/12. Then you should have 30 and 1/8. And then you should have -17 and 1/9. All right, let's do exercise 4 together. Mr. Mitchell lost 10 pounds over the summer by jogging each week. By wintertime, he had gained 5 and 8 pounds. Represent the situation with an expression involving signed numbers, right? We're going to write an expression or a number sentence, and then what was his overall change, right? From June to Christmas, like how much did he actually keep off or gain? So we're going to take that 10 pounds that he lost. He lost 10 pounds. How am I going to represent that? -10 pounds, right? -10 pounds. And he gained, he gained 5 and 1/8 pounds. All right. So how can I write this all out? So here's what I'm going to do. I'm going to write -10 plus, and I'm going to break this into 5 plus a 1/8, right? That the whole thing, that last part is all positive. Now I'm going to combine the whole numbers. I'm going to do this part here. Okay, -10 plus 5. When the signs are different, you actually subtract. Okay, when the signs are different, you actually subtract. And which one's bigger? Yeah, 10 is bigger, so the answer is -5. So I have -5 plus the 1/8, and the 1/8 is positive. Okay, now here's the problem. I don't have a fraction over there with that -5. So some of you are really good and understand how this is going to fall apart, and you're going to be able to find the answer quickly. And others of us, we kind of have to figure this out. So I'm actually going to break -5 into -4 plus 1. But I'm not going to write the number 1. I'm going to write it as 8 over 8, right? Because 8 over 8 equals 1. And I want it to be written as that crazy fraction because it's going to make it easier for me. And by the way, that is a -8 over 8. Okay, because I need it to be a -1. If I write it that way, now I have common denominators. And now I can put these two together. All right, I can put those two together. So the -4 is still out there. And what's -8 plus a positive 1? Well, -8 is the bigger one, right? That's going to be my bigger one. So I'm going to have -7/8. Or I can write it all together, -4 and 7/8. Okay? That's how you can break these apart. You don't need a calculator to do it because you can just break these apart pretty easily. All right, next page, here we go. I know this says it's an exercise and that technically I usually have you work on these on your own, but we're going to do this. We're going to do this together, okay? We're going to do this one together. Jamal is completing a math problem and represents the equations -5 and 5/7 plus 8 minus 3 and 2/7 with a single rational number as shown in the steps below. So we have all his work. We just need to be able to figure out what he did. Okay, so first thing I'm actually going to do though, I'm just going to rewrite the original problem. I'm just going to rewrite that down here. Okay, so -5 and 5/7 plus 8 minus 3 and 2/7. Okay, just rewrote it down there. Now what I want to do is compare each level. All right, what happened? Well, he didn't do anything here. He didn't do anything here, but there is a slight change here, right? He changed that subtraction into adding the opposite. Okay? Subtraction into adding the opposite. Subtraction means add the opposite. Subtraction means add the opposite. Smato. Okay, so just change that over. All right, now let's see, what did he do the next step? Nothing changed there, but those two switched. Well, what lets me switch the order? That's the commutative property. It's the commutative property. All right, now let's see, what did he do next? Oh, what in the world did he do next? He broke those mixed numbers up, didn't he? The opposite of the sum is the sum of the opposite. The opposite of the sum is the sum of the opposite. So we just broke those up. Okay, now what? Now what did we do? Nothing happened with a -5. Nothing happened with a -5/7. But these two switched spots, right? Those two switch spots. When they switch spots like that, that's the commutative property again. Commutative property. Those of you who are going, how did she know to do that? Watch, this is how I remember. I can flip-flop the M's in the word commutative, and it doesn't change the order, right? I can flip-flop the order of those math problems, and it's not going to change my answer. All right, now what did he do? -5 stays. But where'd that -1 come from, right? The 8's there. Where'd the -1 come from? -1 came from adding those two, right? He added. Add the fractions. Okay, then what happened? Then what happened? Where'd -6 come from? Ah, -6 came from those two, didn't it? And everything else stayed the same. So again, he added. Now he's just kind of working his way across, isn't he? Using please excuse my dear Aunt Sally, he added again. And then please excuse my dear Aunt Sally. Oh, the signs are different, right? And we add one last time. By the way, this page here, I'd put a big star on that. I'd put a big gold star at the top of this one. This one is extremely important. I don't know, it may just happen to show up on the test that you guys see. I don't know. Something very, 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 very similar, hint, 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 will be like that, and you probably would want to be able to know how to do that one. All right? All right. So you guys have a great day. I will see you later.